Afternoon, sir.
Thanks, Shamari, for saying good afternoon. Me, I watch Tristan and Adrian. Them just sleeping at the high class. I don't say nothing but big up yourself, Shamari. It's now 19 past. I'm going to give another maybe 6 minutes for persons who are coming in and see what can happen. I have some further updates for you, but let's see what can happen. All right. All right, guys. Good afternoon again. I give you homework last class. Were you able to do the assignment? Hello, somebody? I sent some assignment questions for you. Were you able to do them? Hello? Hello, guys. Good afternoon. How are you doing today?
Afternoon, sir.
Yeah, I've been talking to you guys, but you're not answering me. Were you
All
able to attempt to the question I gave you?
right, for me, sir, no. Actually worked over the weekend.
Okay. All right, Adrian. Mario, Shamari, Tristan, honestly,
But sir, you're not sound 100.
not at all. The flu box me down. Look at
No,
what
man, sir. Right now, you should have drink some tea and have to prepare for bed.
trust me. No, man, I can't. Them will just sleep over the weekend. If I see if I go sleep again. Trust me, man. The flu box me down Friday evening, man, and Saturday, Sunday were rough days. It's a better of me today. Shamari, did you do the homework? Mario, Tristan?
Sir, me never get to attempt it as well. Work over the weekend.
All
Um,
right,
I
go ahead.
try, try to attempt it, but I felt so caught up there, but never get to do it.
Okay. Um, all right. Shamari, how you stay? Were you able to do it tomorrow?
I just did ask you which homework, sir.
Which homework? No, my can't. I joke can't make down. You don't remember it?
No, sir, I don't remember it.
I don't hear you.
No, I don't remember it, sir.
You don't remember the homework? I remember remember oh goodness, same name. Simon was saying that send the answers so that he can see if you're on the right track.
Oh, yeah, I remember that. I remember that. No, sir, I never
Yeah.
do
All
it.
right. So do me a favor. I'm almost rested. By the way, Simon, you do my homework.
Repeat that, sir.
And I was asking Simon if he did the homework. All right, Simon, and all right, do me a favor. Can you all start it now for me, please? Start it now. We won't do all of them in class tonight. Um, but I want to do one or two of them because I must move on. CCCJ wrote back to say that the exam cannot be on the 4th. So the latest date we could get is the 1st of March. So I submitted for the exam to be on the 1st of March. So I will have to, I'll have to speed up so we can finish before at least the 29th of February. So we can ready for Friday, the 1st of March. All right, so I'm going to give you a couple of minutes and you try one or two of those questions for me and then we'll move on. All right, start now for me, please. Obviously, good guys. Anybody finish the first one yet? No answer.
No, say no, finish the first one yet.
No, sir.
All right, go on work. Go on work. All right. Are we finished with are we finished with the first one yet?
Still not as yet, sir.
Which is the first question you're working? Read the function for me.
F, no, 4x squared y cubed plus 2xy minus 6x plus 3 equal 12.
Repeat it from one more time for me, please.
4x squared y cubed plus 2xy minus 6x plus 3 equals 12.
All right. And that's 4x cubed, 4x squared y cubed plus 2xy minus 6x plus 3 equal 12.
Yes, sir.
All right, thanks. Found the question now. Um, so let me just get it now. Is there anyone in the class that completed working this question and got the same answer? Or are you still working at it? Talk to me now. Anybody finished and get the answer, or are you still working at it?
Sir, I just realized I'm doing the wrong question.
Okay. It's not necessarily a wrong question, you know, but so talk to me now. Anybody finish this one yet? The 4x squared y cube. Anybody finish that question yet? Yes, no? So no plan for answer me.
No, sir, not as
We finished working now, sir. I'm gonna get one different answer.
Shamari, you got the same answer as I got?
Mostly it's just one of the term them different. Instead of 12x squared y squared, I got 2x squared 3y squared. So I wonder what I do wrong.
Okay. um, I'm wondering myself. All right, I'm gonna project the question for you. Hold on, let me project. Um, was this a question that you just did, Shamari? Shamari,
Yes,
was it?
sir.
Was
That's
it?
it. I was checking it out. Yes, sir. That's it.
All right. Okay, so let me just go through this question with you. The rest of you, come on. It's not a good look. Exams, well, your exam is around the corner. All right, so it says if 4x squared y cube plus 2xy minus 6x plus 3 equals 12, you're supposed to find dy by dx. Now, 4x squared y cube is a product. I'm multiplying two terms. The terms that I'm multiplying are 4x squared as one term, and the other term is going to be y cube. So I'm multiplying two terms. So I'm going to use the product rule. And the product rule says, the first, once I call the first, I'm going to write it back. 4x squared is the first. I write it back. Times the differentiation of the second. When I differentiate the second, I'm going to have 3y squared. See here? 3y squared. But because I'm differentiating a y, I must have my dy by dx. I must have my dy by dx. So every time I differentiate a y, I must write dy by dx. I'm going to differentiate the y normally as I would the x. But the difference between the differential of the x and the y is that when I finish differentiating the y as normal, I must include dy by dx at the end. Am I understood?
Yes, sir.
Yes, sir.
All right. And then now plus the second, because the product rule says the first times the differentiation of the second, plus the second times the differentiation of the first. So plus the second plus y cubed times the differentiation of the first times the differentiation of the first. When I differentiate the first, I'm going to get 2 times 4 is 8, 8x. And I start at my 8x here. I don't need to write dy by dx because the only time I write dy by dx is unless I'm differentiating a y. So that ends the first term plus this one now. It's a product again. My product will be 2x as my first term and y as my second term. So it's the first times the differentiation of the second plus the second times the differentiation of the first. So watch me. The first is going to be 2x, see here, times the differentiation of the second. When I differentiate y, I'm going to get 1, but I have to write dy by dx because I am differentiating a y. Plus the second, see here, plus y, times the differentiation of the first. When I differentiate 2x, I'm going to get 2. So that's why I have this here. And when I differentiate negative 6x, I'm going to get negative 6 right here. And when I differentiate 3, I get 0. When I differentiate 12, I also get 0. So that's why I have those there. And then all I'm going to be doing is just fixing it up. I'm going to fix it up. 4 times 3 is 12. X cubed, y cubed, dy by dx. 8 times y cubed times x is 8xy cubed. Right here. And 2x times 1 is going to be 2x dy by dx. 2x dy by dx. And y times 3 is 2y minus 6. My aim is to put all the dy by dx together and everything else over the equal sign. So I'm grouping or simply I'm rearranging, putting all my dy by dx's together. So I'm going to have 12x squared y squared dy by dx right here, plus 2x dy by dx right here. And then I'm going to have my 8xy cubed, my 2x minus 6 on this side right here. And then what I'm going to do now, I'm factoring up my dy by dx, and then I will eventually subtract 2y plus 8xy cubed minus 6 from both sides. See here? I'm subtracting this. So I just put it in parentheses. I'm subtracting those. And then what I'm going to do is to divide both sides by 12x squared, y squared plus 2x, so that I can leave my dy by dx alone on one side. So what it is that I have in red will be my final differentiation answer for dy by dx. But the question gave us a conditionality. It says to find dy by dx at the point when x equals 0 and y is equals to negative 1.
I never said that part of your question on you, sir. Oh, you do it after the solution. You put it after the solution. All right, that's it. That's it.
Yeah. So Shabari, are you able to see your mistake? Now you said you never get one part of the answer. You see the mistake now?
Yes, sir. Me put it up.
Okay. Um, Adrian, Mario, Simon, honesty.
Yes, sir. I'm looking on following.
Okay. Mario, Adrian.
All right, sir. I'm just reach home. I go up on my laptop now. Just reach home.
Uh, Mario.
So sir, I'm going do the other question, the man.
Yeah, man.
Senior.
Try one more for me, please. Try one more for me, please, because I really want to move into other things, and you need to understand this piece here. So try one more thing. Try one more for me, please. No, hold on. No, hold on, because I need to finish off this one here. So it says, so to find the value of dy by dx at the point when x equals 0, y is equal to -1. So when it says 0, -1, the first one is the x value, and the second one is the y value. So anywhere in dy by dx here in red, I see x, I'm going to put 0. So what is going to happen, and y is going to be equal to -1. So that's what I did here. Y is equal to -1, so it becomes 2 times -1 plus 8 times 0, because x is 0, so all of this goes to 0, minus 6 over 12 times 0 squared, -1 squared, plus 2 times 0. So we can get something like this undefined. It's something that is undefined because the denominator in and of itself is 0, while the numerator is going to be equal to +8. So we have 8 over 0, which is really undefined. So dy by dx in this case, at the point 0, 1, -1, is undefined. At another point, it exists, but at this point, 0, -1 is undefined. So, so you do that, you write up to say that the function is going to be undefined at 0, -1. Fair enough?
Yes, sir. Fair enough.
All right. Which was the other question? Which was question 2? Tell me what question 2 was again, please.
A function is defined implicitly by 3x cubed minus 2xy squared equal 13. Find an expression for dy by dx.
And that's a past paper, right?
Yeah, past paper 2008 May.
May 2008, all right. Start that one for me, please. I'm going to give you 3 minutes. Start that one for me, please. Mario, come Adrian, hurry up and get the books.
Got it, sir.
All right. You got the same answer I got.
Yes, sir.
Good job. The rest of you, I'm very concerned that the rest of them not participating, you know. So that's what you got, right, Shamari? All
Yes,
the
sir.
negatives.
Nothing is being shared on your screen now, but yeah, I got the
Oh,
solution that you sent it
sorry,
there.
sorry, let me share the screen. Sorry, I apologize. You see it?
Seeing it now, yes, sir. That's what I got.
Good job. Tristan, Mario, so which one was number 3, please?
Number 3 says differentiate the implicit function x squared y minus 8xy plus 4y equal 5. Find a value for dy by dx given the point minus 1, 2. What work it, sir?
I'm going to work it, but for those who have not done the assignment and still not doing anything, even though I asked you to do it in class, for your sake, when I go into the recording, let me just do it again. So the question says, fine, and it's not my question. This is a past paper question. May 2008. Find a function is defined implicitly. Remember, an implicit function is a function that contains both x and y. We call them multivariable. But the explicit function has y equals to some value of x, where one is a dependent variable and the other one is an independent variable. So we're supposed to find the implicit differentiation. My 3x cubed is a standalone. So I'm just going to differentiate that normally. And when I differentiate 3x cubed, I'm going to get 9x squared. That's what I have right here. All right. So it's a product. So I'm going to differentiate 3x squared as a standalone. So I'm going to get 9x squared. I'm going to get 9x squared. And I'm going to get 9x squared. I just said it and I'm not seeing it now. I'm going to get 9x squared. And then when I differentiate 2xy squared, 2x y squared is a product. 2x, the first term, is being multiplied by y squared, the second term. So it's going to be the first times the differentiation of the second plus the second times the differentiation of the first. So the first, ballet, the second is going to be by y squared. So I'm gonna put it. Oh Lord, I should put this in parentheses, but anyhow. My first, which is my 2x, times the differentiation of the second. When I differentiate the second, I'm going to get 2y right here. Then I have to write my dy by dx plus the second, which is y squared, times the differentiation of the first. Something is wrong with this question. I should have had all of this in parentheses because all of this here, so this is supposed to end up being a negative. That is what I'm talking about. Hello?
Yes, sir. That's what you're talking about.
Yeah, man. So this is supposed to be a negative. Let me see if I can. Let me go for the pen and correct it on this. Hold on a minute, please. All right, so that should be a negative. So what I'm doing here is to say 9x squared minus 2y squared is equal to 4xy divided by dx, and then dividing both sides by 4xy. That cancels that. So I'm going to have divided by dx is equals to 9x squared minus 2y squared all over 4xy. Are you with me?
Yes, sir, I'm with you.
All right.
Yes, sir.
Okay, thanks, Simon. Mario, Adrian, honestly. All right. One last one. This was one of the questions, right? Was this one here one of the questions? X squared y minus 8xy plus 4y equals 5.
Yes, sir, this is one of the questions.
All right, so let's go. But by the way, were you able to get this one at attempt? You did this one already?
I should have, but no, sir, I'm going to do it now.
All right. I'll give you 2 minutes. 2 minutes to try it for me, please. Simon, please. Try it in 2 minutes for me, please. And thanks. Honestly, we finish the question yet?
Working out the last part now where it asks about the point.
All right, hurry up.
Finish now, sir.
Good job. Simon Hoisty.
So I'm trying to figure out how about the numerator because I have a negative 2xy, but that's supposed to go in the denominator.
Negative 2x is supposed to be in the denominator.
Yes, sir, because of the factorization. But I'm not sure. Probably something went wrong in my working out.
You can tell me if you agree with that. Shamari, Simon,
Sir,
look at me if you agree with that.
when we factorize it 4y, we never put dy by dx, so don't let that throw off everything, sir.
Yeah, man, remember now. We have to get to our dy back. We have to get the dy by dx.
Yes, sir. Simple mistake.
Mm-hmm. Simon Hoisty.
Sir, I'm still looking.
Still looking, okay.
Sir, when we differentiate y, we have to put dy by dx, right?
Yeah,
That's it.
I said yes.
Yes, sir.
Okay. So to do the explicit differentiation, once I differentiate in an x, it's just the regular differentiation. When I'm differentiating a y, it's a regular differentiation, but I have to put dy by dx at the end after each y that I differentiate. I remember now, you can differentiate the y regularly as if you're differentiating the x. But at the end of differentiating the y regularly, you can end up putting dy by dx. And you have to be consistent. Sometimes when you do the question, you may end up with all three dy by dx into the question. Don't worry about it. Just factor it out and come back dy by dx, and you should be good to go. You should be good to go. So in this question, it's the first times the root over the second. The first is x squared, and the second is y. So it's going to be the first, which is x squared, times the differentiation of the second. And when I differentiate y, normally I'm going to get 1, but I end up having dy by dx. Plus the second, which is y, times the differentiation of the first. And when I differentiate 2x, I'm going to get, no, when I differentiate x squared, I'm going to get 2x. And again, what's wrong with me? It is supposed to be in parentheses. The first, which is x squared, which is 8x, times the derivative of the second, which is 1, dy by dx, plus the second, which is y, times the differentiation of, okay, I'd have taken into consideration. All right, so I don't need a parenthesis right here. I'd have taken that into consideration, plus 4y dy by dx. All right, so that line is correct. And then I'm going to say x squared times y is x squared dy by dx. And 2x times y is 2xy minus 8x dy by dx minus 8y plus 4 dy by dx. Right. So in this case, we have 3 dy by dx, 1, 2, and 3. All I'm doing is putting all of them together. And then this positive 2xy goes on this side here, and the negative 8y is here. So I'm factoring out the dy by dx. When I factor out the dy by dx, I'm going to have x squared minus 8x plus 4 times dy by dx. X is equal to 2xy minus 8y. I'm going to subtract all of this from both sides. So when I do that, I'm going to end up with a negative 2xy and a positive 8y. And then I'm differentiating now. I'm going to divide both sides by x squared minus 8x plus 4 so that I can get dy by dx alone on one side. Tell me that you are following what is in blue here.
Yes, sir, following.
Yes, sir.
Good job. And then now, I'm not even aiming to simplify anything there because it says at the point where x is equal to negative 1 and y is equal to 2. So I have negative 1, 2. Anywhere in the function dy by dx, I see x, I'm going to put negative 1. Anywhere in the function I see x, I'm going to put in 2. So let's go. 2 times negative 1 times 2 plus 8 times 2 all over x squared is going to be negative 1 squared minus 8 times negative 1 plus 4 minus 2 times 1. Negative 1 is positive 2, and 2 times 2 is 4, and 8 times 2 is 16. Denominator now is negative 1 squared is 1. Negative 8 times a negative 1 is going to be positive 8, and you carry out the 4. 8 and 1, 9, and 4, 13. So I get 20 over 13. Hmm? Are you
Following,
following
sir.
what? Following?
Yes, sir. Following.
How you feel now compared to last class? You think you get a little bit more?
Yes, sir. I'm getting it.
All right, good job. Simon, how you stay?
Sir, I'm all right. I'm getting it. I saw where I went wrong last time with the negative 2xy.
Okay.
So basically, we have 3 weeks to finish up and do Edicus off and everything, right?
Yes, sir. All right. So that's it. That's the end of my explicit functions. You already know how to do the implicit functions. Pay attention to this question. It loves to come for some 7 marks to 10 marks. Please pay special attention. I didn't do the square root. I didn't do the square root differentiation with you.
Oh, sir.
All right. So all right, let's go. So y is equals to the square root of 2x plus 3. Remember, when you're doing indices, once I have something to be called the square root, it's going to be something raised to the half power. Or sir, there is an imaginary 2 that is written inside there. You don't write the 2 in the sleeve of the square root sign because it's redundant. But what happens though is that it goes in the denominator of my power. So if I give you the cube root, you expect it to be something raised to the 1/3 power. Do you agree with that?
Yes, sir.
So let us attempt this
Yes.
question now. This question says, y is equals to the square root of 2x plus 3. That 2x plus 3, I'm going to put it in parentheses, and I'm going to raise it to the 1/2. See it up here, so That's it. Once you have something, once you're asked to find something for the square root, you're going to remove the square root sign, and it's going to be raised to the half power. Very important. Are you okay?
Yes, sir. Looking.
All right, now. So when you have your function, y is equals to the root of 2x plus 3 is the same thing as saying 2x plus 3 raised to the 1/2 power. When I'm finding dy by dx now, it's going to be equals to a half. Remember the rule. That half is going to multiply in front of here, and then we're reducing that by 1. All right, and then we're going to times that the differential of the inside, because this is not the power rule. That's not the power rule. So dy dx is going to be equals to a half times 2x plus 3. A half minus 1 equals
Minus half.
minus a half times the differential of inside the parentheses. When I differentiate inside the parentheses, what do I get?
2.
2. Very good. Now watch this. When I multiply those two, it's going to give me a whole. 2 halves make a whole, don't?
Yes, sir.
So dy by dx then is going to be equal to 2x plus 3 raised to the negative 1/2. We never normally write our index as a negative answer. We never normally write an index as a negative answer. So you have to fix it up. So dy by dx is going to be equals to 1 over 2x plus 3 to the positive half. It was negative half. It now becomes a positive half. But we know that anything raised to the power half is going to be the square root. So it's 1 over the square root of 2x plus 3. Look at the activity. Okay, guys.
Looks good, sir.
Mm-hmm. I'm starting my
Sir, looks
integration.
good.
All right, good job. So starting integration on Monday, on Wednesday. Wednesday's holiday, don't.
Sir, Ash Wednesday and
Yeah. So we're not gonna have any class on Ash Wednesday. All right, let me see if I can use the 3 minutes here and go through this. All right, let's go. So onto the rules of integration now. So they said that the following rules for integration for indefinite integral are obtained by reversing the corresponding rule for differentiation. Their accuracy is easily checked by taking the derivative or the antiderivative, which is the integral, to be sure it equals to the integrand. The elongated S is a sign for integration.
Excuse me, sir, you're not sharing the screen.
Okay, thanks. See it now?
Yes, sir.
All right, so I don't want you to study these things as rule 1, rule 2, rule 3, rule 4, all the way up to rule 8. I don't want you to do that. I'm just giving you the rules. The integral of a constant k, when I integrate a constant k, I'm going to get kx plus c. And c is known as a constant of integration. C is known as my constant of integration. So when I integrate a constant, for example, if I integrate x, no, if I integrate 5, when I integrate 5 with respect to x, I'm going to get 5x. Because when I differentiate 5x, I get 5. All right? So it says their accuracy is easily checked by taking the derivative of the antiderivative to be sure it equals to the integrand. All right? The integral of 1, written simply as dx, not 1 dx, is this. The integral of 1 is going to be x plus c, which is like the example I just gave a while ago. Rule 3 says the integral of a power function, x to the n, where n is not equal to -1, is this. This is a rule here for integration. What we say for integration is that we add 1 to the power and divide it by the new power. We add 1 to the power and divide it by the new power. That's how students appreciate the rules for integration. You add 1 to the power, divide by the new power. And then the integral of x to the -1 or 1 over x is going to be the same thing as ln x plus c. Are you okay so far?
Sir.
All right, so just remember, when you integrate x to the -1, it's going to be ln x. The only time you get ln x is unless the power is exactly -1 that you're integrating. If you integrate it when it's -2, you're going to get an answer. So -1 is very special. All right? And then I use the absolute value here because you can't take the negative value of a logarithm. Only positive numbers have logarithms, right? And then rule 5 says the integral of an exponential function is the exponential function itself. Sorry. Is the exponential function itself. Then I'm going to multiply. No, I'm going to differentiate the power. I'm going to differentiate the power. I'm going to reciprocate it. So e to the kx. When I integrate e to the kx, I'm going to get e to the kx. But I'm going to differentiate the kx. I'm going to get k. And I'm going to reciprocate that k to give me the 1 over k. All right. And then the integral of a constant times a function equals a constant times the antiderivative of the function. Watch me. The integral of kx, the integral of k f of x dx. K is a constant. So what I can do is to take out the constant and just integrate the function f of x and leave k outside. And I finish with my answer, and I just multiply everything by k. So that's what that rule is saying. This other rule here, the sum or difference rule, is saying the integral of f of x plus or minus g of x is the same as integral of f of x dx plus or minus g of x. So instead of doing everything one time, I can split it up and do it. That's what integration is saying. And then now, it says the integral of a negative function equals a negative function of the integral. This one, number 8, relates so much to number 6. Because I have a negative one out here, which is like a constant, I can factor it out. I'm going to factor it out. I'm going to have the integral of f of x dx. I just go ahead and integrate it f of x dx. So this here is the same thing as this. It's just that my k is equal to negative 1 in this here case. And that's the end of the rules. And I can send the rules here to you. And God's willing, when we meet again, we'll go through the stuff. All right. Thanks for coming out.
No problem, sir.
All right, sir, and hopefully get some rest, sir, and get well.
My man, I appreciate it. Thanks.